Hello everybody and welcome to our new textbook, College Algebra and Trigonometry 7th edition. And we're going to start with Chapter 2, Sections 1 and 2. And the very first topic that we're going to cover is equations of circles. And we're interested in finding the equation of a circle if we're given its center and its radius, or finding the center and radius if we're given its equation. And we should also be able to deal with what's called a general form by completing the square, which is something we should be familiar with at this point. So what do we say as this specifically as our circle in its equation? This is what we call a standard form equation right here. When we say we have an equation of the form x minus h squared plus y minus k squared is equal to r squared. How does this one come about? Well, if you think about what's actually happening here in this circle, if I were to draw my x and y axis here again, and I'm interested in finding all of the points that are equally distant from a given point, we'll call that point h and k, and another point somewhere else in the plane, x and y. For the points h and k, if you recall what the distance formula looked like, what we would be interested in doing is setting up an equation to find this distance. And of course, all of the points that have this distance, this fixed distance away, make up all of the points along the outside of the circle. So how do we find that? Well, recall that the distance formula, we're calling that distance r. So let r equal our distance. Would be equal to the square root of the difference in the x values, so x minus h squared, right? So this x coordinate minus this x coordinate squared, plus y minus k squared, and that's our distance r. So if we want to get rid of the square root on both sides, we square both sides, so r squared is equal to x minus h quantity squared plus y minus k quantity squared. And this is our standard form. By the way, if the center is at the origin, 0, 0, then we can rewrite our standard form equation to look more like x squared plus y squared is equal to r squared. And so this is the basis on how we're going to deal with functions like this. So let's use this standard form to help us figure out some basic information about some circles where we already have this equation in this given form. So in example A, we're asked to find the radius and the coordinate of the center of the circle for the equation x squared plus y squared equals 5. Well, how would we do that in this case? Just as we stated before, if the center was at the origin, x minus 0 would just be x squared, and y minus 0 would be just y squared. So our center is very easy to find in this particular case. We're going to say that the center is the coordinate point 0, 0, the origin. Well, if this is the case, of course, now we're saying that r squared, the square of the radius of our circle, is equal to 5, because it's x squared plus y squared equals r squared. So r itself is equal to the positive of the square root of 5. And remember, since r, the radius, is a distance, we always give it a positive value, so we would never have the negative square root of 5 as our radius. Well, how about our second circle over here? We've got x minus 1 squared plus y plus 3 squared is equal to 4. Well, if we make this fit with our standard form model over here, x minus h squared plus y minus k squared, is set it equal to r squared. What are we saying? Well, it looks like we're saying that h is being replaced with 1, k, is being replaced with negative 3. Why negative? Yeah, that's right. The subtraction of a negative becomes plus. And of course, r squared is equal to 4. So what could we say? Our center will be located at the point 1 for x, negative 3 for y, and our radius will be at the point, or will be radius. Boy, that's not a very good way of spelling radius. Let's try that again. Radius will be equal to 2. Makes sense? So far it should. All right, one last one here. Let's find the equation of a circle, and we'll put it in standard form, of a circle that has a radius of 3 and a center at negative 2, 4. Well, if we use this model up here, we're going to say then that our circle's radius of 3, r squared, will be 9. Let me make that straight. R is equal to 3. H will be equal to negative 2. And K would be equal to 4. And so in our model, we would write x minus negative 2 squared plus y minus 4 squared. That should have been a 4 over here. I don't know what happened. Losing my mind. Is equal to r squared. So if we write this out, simplifying it, we're going to have x plus 2 quantity squared plus y minus 4 squared is equal to 9. That is our equation in standard form. And so we're done. More in the next video.